Energy system analysis. Our hypothesis was that we predict that we will use the aerobic energy system in this exercise test. We could predict which energy system was going to be used by measuring the O2 saturation done by readings from a pulse oximeter and taking a blood sample during the test, which is used to measure lactate levels in the blood. Rachel's results were the most like our hypothesis and prediction of what energy system was going to be used by calculating the lactate levels in the blood. If there was an increase in lactate levels, it would suggest that there is no oxygen present to eradicate the lactic acid. We predict that the exercise would cause the participants to work aerobically and use the aerobic energy system because there is a constant supply of oxygen. For Rachel, we can see that she did use the aerobic energy system at some point during her exercise. This is because her lactate levels decrease, and this could have been due to the continuous supply of oxygen when participants work at a steady state. As well as this, the O2 saturation reading for Rachel suggests that she was working aerobically because a high O2 saturation means a large amount of oxygen is being supplied. Even though her O2 saturation decreases rapidly to around 63%, this could have been due to incorrect readings that were taken due to a fault in the experimental method or the equipment, because after this it did rapidly increase back to an accurate reading. The lactate levels of Luke start at around 9.3% and then rise to around 20.9%. Compared with normative data which states during steady state exercise the lactate level should only be 2 to 3%. This suggests that Luke was not using the aerobic energy system because there should be less lactate as a result of eradicating the lactic acid due to the presence of oxygen. However, his readings of lactate levels could have been due to faults in the experimental method, because the readings for his O2 saturation show that he has a high O2 saturation, and this suggests that he is working at a steady state and using the aerobic energy system because there would have been a constant supply of oxygen and O2 saturation would be high because of this. The next set of data that could have been analysed was Billy's O2 saturation and lactate levels. As we can see in the graph, there is a rapid increase in the lactic acid buildup when Billy was carrying out the exercise. This suggests that Billy was using the anaerobic energy system and that he was not working at a steady state. If Billy was working at a steady state, the lactate level would not be above 10% whilst doing exercise. This reading, however, could be contrasted if we use the O2 saturation graph. If Billy was working at a steady state, there would be a high O2 saturation, and it would plateau after a certain amount of time. As we can see in the graph, there is an increase and there is also a definite plateau at around 10 minutes of exercise, which shows he could have been working at a steady state. However, this high O2 saturation could have been due to incorrect readings from the equipment as well as Billy's extremely high breathing rate. Do I agree with the hypothesis? After analysis, I still accept our hypothesis. This is because if we had a standardized method and everyone followed them, then the data would have been closer to the hypothesis. As well as this, if the equipment such as the pulse oximeter was easier to read, and also the blood pressure monitor gave readings, then the data would have been closer to our hypothesis. This is because some of the readings were incorrect. This meant that the administrators were making test subjects work harder or easier, which led to a fluctuation and incorrect data.